Greetings, programmers. Professor Bland here. Let's take a quick look at using the debugger in code blocks. A little bit of a review here, but always helpful thing to make sure that you're on top of. Like our mug there, definition of debugging, being the detective in a crime movie where you are also the murderer. Uh, Debugging has a lot of aspects to it, and so we're we want to try and make this as simple as we can. And so this is what the debugger in the code blocks programming environment does for us. So let's work with a little better definition of debugging. What is it? Debugging in computer programming and engineering is a multi-step process that involves identifying a problem, isolating the source of the problem, and then either correcting the problem or determining a way to work around it. Final step of debugging is to test the correction or workaround and make sure it works. This is nice, wordy from techtarget.com. Shorter one, debugging, the art and science of fixing bugs in computer software. Boy, that just gets right to it. So what is a debugger? Why do we care? Well, it goes to how you debug a program. And there are tips and techniques and tricks that you can use. You can use metering code, which prints lines in your output or on a updated window or something like that. We call that metering code that updates as you goes, and then before you release your final product, you take that code out. And there's any number of ways you can do that by deleting it or using pound defines or any number of ways. You can have your program write to the syslog process, which is actually a pretty handy thing. It's a standard process that runs in most computers, and you can filter that. There's a lot of processes that talk to syslog, and you can filter for your application and look at all its syslog messages coming out there. You can do that. You can use debug logging, where your own program writes its own debug log file, and both this and syslog take overhead time from your program in order to do these things. And you don't want to leave that in your code long term. We could use debugging tools. There's external hardware debuggers that are pretty miraculous. They're also pretty expensive. Most of the time, you're not going to need something like that. You're going to use the software tools. And if you get lucky enough, maybe you've got a nice standalone one, but also you can use them that are part of the IDE, which is what we're going to do. Code Blocks has a built-in debugger. It allows you to set breakpoints. Now, breakpoint is a place in a program where the execution will stop, and that allows you to know that part of the program executed. You can examine variables while you're there. You can start line-by-line execution. Breakpoints can be made to have conditions on them so that execution will only pause at that breakpoint if the condition is met. You can set watches on the variables, which is really cool. You can look at the contents of a variable in a separate window. You don't have to print it in your program. The debugger does that for you. It pops it into a little watch window and displays the current value of all the watched variables. Hopefully you can see a little creative use of this kind of tool will help you isolate and correct problems in your program. So how do you use it? So when you create a new project in code blocks, you want to make sure that you have create debug configuration checked. If you don't do that, the compiler will not include the information it needs to do debugging. This release configuration, and you'll see in a little bit how we could select, are we going to do a debug version, or are we going to do a release version? The release version doesn't have all the extra stuff in it for debugging, which makes the code a little bit more compact. So it doesn't hurt to run with both, but debug configuration is quite optional. So make sure that is checked. You're going to need that. You want to make sure on the toolbar that the debug configuration is selected, and when you build the project, click on the gear, but don't use the green arrows, because these will run it without debugging. It doesn't hurt anything, but the point is it doesn't let you do what you intended to do. So build the program by clicking on the gear in debug mode, but don't use the green arrow tools because you don't want to run in release mode. This is a view of the debug toolbar and all the features that are on it. We're going to start our way here from the bottom. Run and continue debugging, run to cursor, execute the next line of code, step into the function, step out of the current function, pause the debugged program, terminate debugged program, and show debugging window menu. We're only going to use 2 or 3 of these on here just to get us through this little demonstration today. So we've got this program. This is what you're going to be doing eventually in this class, and we're reporting some distance moved here by this object, but you notice it takes this jump out here, and this looks, wait a minute, how did all of a sudden we go 6,400 miles? Something's wrong here. And you kind of get some hints at looking at on here, but the distance is certainly a good hint. And maybe we got a problem with our coordinate data because you notice there's a minus sign missing here. So let's use the debugger to find out what is going on. So let's switch screens over to our program. And here we've loaded our program and our code. So I'm going to go up here and I am going to click on build. Notice I have selected that I want the debug target. Okay, there it is. Then run the program normally. I have to go over to this other window and drag the program output over here. I'm going to scroll up in here. You can see this is my error, but it just screams right by it and doesn't give me a chance to examine stuff. Well, this is what the debugger will let me do. So I'm going to, in my source code, set what I call a breakpoint. I'm going to go down here to this read line call. And I'm going to click right here beside the line number. And you see that red dot? That says I have a breakpoint. So now if I say run in debug, go over here and get my program output, it has run up to that point and stopped. You see the little yellow triangle right there? That means we have stopped at that line. And we've printed the information line debug program. You can see there it is right there. And I've stopped right there. Okay, that's all good. But I noticed that my data was corrupted, and I'm filtering for KC6YIR. And so I would like for this to stop on every data line for KC6YIR. All right, well, that's fine. What we can do here is we can hover over this red dot, right click, and let's edit our breakpoint. And you'll see here that I'm checking every line. Is KC6YIR in there? And if it is, then I'm going to set this to 1. So I'm going to say now only stop on the breakpoint when stop here equals 1. So instead of this stopping every time it calls read line, it's only going to stop here at the read line call when the last time through KC6YIR-1 was the call sign. So now that I've done that, it may seem a little unnecessary to set this conditional filter, but here's the difference. I'm only stopping at this read line after the previous line was the call sign I was interested in. Even though it's filtering and only printing out these lines, I don't want it stopping at every read line. The read line isn't conditionalized in terms of it's always going to read every line. I want it to stop only after I've read a line from here, from this call sign, KC6YIR. So that's why I've got that conditional on there. So let's continue to repeatedly step till we get to our problem data. Okay, there it is right there. So let's examine some variables. This is where we can set the watch points. So first of all, let's set a watch point on our input array where we're reading our data. This lets us see what we've just read from our input file. So I can right click on that name and say watch line array. So you can see over here in the watches window, here's my variable line array. Here is the contents of it. All right, let's look at some more. Let's also watch previous location and current location. So let's scroll down here a little bit. Let's right click on current location and say watch current location. And let's right click on previous location and say watch previous location. Let's also put a watch on distance moved. Now you notice on distance moved, if I hover over it, it tells me, well, it's a double, but it doesn't tell me anything about the value. But over here in my watch window, I can see distance moved is 6,421.08, blah, blah, blah. It shows me the distance. But look at current location and previous location. If I hover over these here in the source code, notice it says it's a pointer. Okay, and that's what it's showing us. It's a pointer, but I actually want to see the values there. So I'm going to right click on current location and I'm going to say dereference current location. Now you see this plus sign has appeared. I'm going to click on that and look, there are my two structures inside current location. And if I click on that latitude structure, it lets me see the degrees, minutes, and seconds. And same thing for the longitude. So I can now examine these variables in detail. This is what the watch window lets us do. But this is a little bit of a digression because really in order to, we looked at this data here and we said, you know what, that minus sign is missing. What's that? There's got to be some kind of a problem with our data. And if we look here, we'll notice our longitude is east longitude, which would make that a positive number instead of a negative number. If I let this go another round, see here it is, west. That's what it's supposed to be. That's what gives us a minus number. So we've got some problems with that particular data line. So we can open our data file and we could search for that text that we saw was wrong, 11845.64E, and here it is on line 420. So I could change that E to a W. Okay, it's not going to let me save it. Let's close the debugger. I've changed it. I need to save it. Something's still open. Who's still running? There we go. Got the debugger stopped. Save the file. Start it over again. Grab my output file, bring that back up here where we can see it. And now as I step through each one of these, and you notice no more errant data. And all the lines are supposed to be as they are. So this helped us examine our variables, see what was going on. We could use these same things, looking at these structures and these calculations. We can use that is our math right? That'll help us see all of that in there. So that's how you can use a debugger to your advantage. Let's go ahead and terminate that. If you have any questions about this, get a hold of me and we can talk a long time about this.